Hello viewers, welcome to TSET program organized by Government of Telangana, Commissioner and Director of School Education and State Council of Educational Research and Training. Mathematics Day. Once we thought about mathematics, we can see some sort of fear in some of the students. But in our country, there are several great mathematicians like Bhaskaracharya, then Pingala, Madhavacharya, human computer Shakuntala Devi, Manjula Madam field medalist and so on. Though there are several mathematicians, we celebrate Mathematics Day on the birthday of Sir Sri Srinivasa Ramanujan. What is his specialty? If we think about Ramanujan sir, in the words of Professor G.H. Hardy, he gave a rating from 0 to 100 for the mathematicians. For himself, G.H. Hardy himself, he gave 25 in the scale of rating of 0 to 100. For Littlewood, he gave 30, and David Hilbert, a great German mathematician, for which he gave 80, but for Srinivasa Ramanujan sir, he gave 100 rating, that is the highest rating. So we can understand that Ramanujan's raw ideas are more and more helpful in attracting J.H. Hardy's. Okay, now we know that Ramanujan was born on 22nd December 1887 in Erode, Tamil Nadu. And on behalf of his birthday, we are celebrating Mathematics Day in our schools. Now, let us discuss about the Mathematics Day, how it should be celebrated in schools and how is it being celebrated now, what sort of activities must be conducted so that we can create thinking in the young minds. Okay, to discuss these things in the studio, there are few experts. This is PDL Ganpat Sharma, faculty SCERT. With me, the team members are, to my left, the first person is Sri KKV Rayalu sir, retired principal CTE. He is a well-known mathematician as well as textbook editor. He has vast experience as a teacher as well as a teacher educator. Okay, and to his next is Mr. R.L.N. Murthy, who is also subject expert in mathematics as well as a textbook writer. And one more professor, retired principal are there. He is going to join us soon. Meanwhile, we will continue our discussion. Sir, Rail sir, nowadays what sort of activities? Actually, we are conducting Mathematics Day in schools. Yes. What is our expectation in conducting the Mathematics Day in schools? Can you give briefly about that?
Yeah, it should build positive attitude towards mathematics. Because many children are afraid of mathematics. Even other than mathematics teachers also, they avoid to talk or explain whenever the content comes in their subjects. Okay. So we have to improve the positive attitude within the children, then develop logical and critical thinking. This is most important for each and every subject, but much reflected in mathematics. So wherever logical thinking and critical thinking is needed, even deep thinking also needed, we have to encourage children to aware of those things. Okay. And connect through mathematics to real life. So everywhere where we go to, everybody says that there is a lot of mathematics needed for our real life, but teacher has to give a very good connection between wherever the subject areas are there and real life situations. Even examples also the teachers has to be taken from real life situation and inspire the students, the role models. Even Hardy said that Ramanujam is a 100 score is there, like that Euler was there. So Euler was having tremendous control on numbers, theory of numbers.
Fantastic.
1 to 10,000 numbers, he could tell any factor, any divisibility numbers, anything if you ask. Like that, more than that, Ramanujam was having about that. Ramanujam was a very silent, passive mathematician from India. Even he is very submissive. But Euler, the context is different. Euler context is that's the reason Euler is very popularized than Ramanujam. Okay, then encourage the joyful and activity-based learning. So mathematics, until unless the children will be 3-4 types of auditory children and the logical children and visual children will be like that. Children will be categorized. So for each child, the teacher has to create a joyful learning. Okay, then activity based. So activity based means in that activities every child individually they immerse, they think. So that is very much important for the classroom activity. Then identifies the nurtures mathematical talent. So every mathematics teacher should evaluate the child perfectly. What are the lacunas and what are the gaps within the children to make in the mainstream as well as in mathematical, one style of building a ladder, where he stood. Some children we can silently or like the children will be there, 6th class children able to do 7th, 8th class problems also. So a teacher has to identify and nurture their levels. Okay, that, yeah.
Yes, sir. Actually, like we can see, Ramanujan is the best example. Somewhere I read that he solved trigonometry problems when he was at younger age.
Exactly.
And actually, he was inspired with the books of like S.L. Loney's trigonometry as well as Carr's number theory book.
Yeah.
He solved the theorems in his own.
Yeah.
So, a very young age, he could be able to answer so many problems and theories from that.
Yes.
That is really fantastic, sir.
Yeah.
But sir, Murthy sir, can you tell me for Mathematics Day, what sort of activities are being conducted in the schools in general? Like, can you describe about the things which are happening in the schools?
So, good morning, everybody. So, in general, generally in school, we conduct the programs. So, by displaying the charts in the classrooms, or by decorating the classrooms with mathematical symbols and etc. Even some history of the great mathematicians, so Pingala, what you said, Madhava, or even Euler,
yes.
Carl Friedrich, Gauss, and even Ramanujam.
Yes.
Their all photographs will be displayed in the classrooms. And besides that, even they prefer for even Rangoli also, the mathematical Rangoli. So which actually in which they incorporate the mathematical formulae and symbols. Sometimes during even prayer time also. So the students will be arranged in such a way that 1729 number of taxi number, that is a very familiar number.
Yes, of
so
course.
Generally we conduct the programs like this. By generally we conduct mathematics quizzes also, conduct allocation, and also even essay writing programs will be conducted. So general these kind of programs will be conducted at the schools.
Okay, fantastic. Then, sir, actually these sort of activities, whatever are being conducted in the schools, will they be sufficient, and what actually we are expecting from conducting these activities in the schools? Sir, can you elaborate that?
Yeah. Every teacher has to think the students' levels of the school children. So this will be different from schools to school. So one school, the children may be very good in arithmetic, or other school maybe in algebra or geometry or like that. So teacher has to evaluate the children perfectly. And Ramanujam is inspiration, but this inspiration we have to bring into the classroom activities done by the children. So children are most important. Children has to, we have to visualize children as future Ramanujams more than Ramanujams. Okay, so for that what are the lacunas, gaps in the children, and they are lacking behind the classroom activities, that we have to, every teacher has to evaluate the children properly. Then only they can develop the skills. Until unless we know the child, what is the child, we cannot help him. So that for that some questionnaires also we can done from class 1 to fundamental concepts to a little bit higher concepts, like that. A question bank we have to prepare and give to the children, and in that at least 10 questions for each. For example, additions, if you give different kinds of additions, 10, and multiplications, then we can understand what kind of multiplication or what kind of addition the children are not able to do. So for that, then we can give a little package for the child, question bank or like that. Then the child will develop that skill also. So this is like a comprehensiveness. Okay. So that rather than that, please.
Sir, actually, while reading about Ramanujan, we have read that he will solve the problems with intuition and rigor.
Exactly.
Can you give a little bit of elaboration about that?
Yeah, intuition is built in every child. According to psychology, intuition means, for example, if you draw a line, a straight line, please draw a straight line. So if you ask, so where that next where that line go, back side or down or upper, that. So the child will definitely tell that extension of that line. Please extend that line. Generally, you think that you are a child. Yeah, if you ask the child, you can draw a traverse line. Yeah, like that. Okay. So here we can understand where that line goes. The child will give that correct answer, that giving that. So if you ask the question, how you are telling the answer, can you give reasoning or any logic is there? The child cannot tell, oh, no, I don't know the logic or method or anything, but I know this line will go in this direction only. But what is happening within the child, that is most important. Every human is different and their mind is different. So the mind, within the mind, it is calculated the slope of the line, and that slope will be extended to upside. Then the child will tell the line goes that. But child is unaware of his inside. That's the reason all mathematical philosophers tell that every human know yourself, what your brain is thinking, and you connect with that.
Means knowingly or unknowingly he will get the final stage.
Exactly.
Or the answer he will expect.
Yes.
Okay. Fantastic. And what are the other factors which are to be built through the activities, sir, along with intuition?
Yeah.
What are the
intuition? We need the basic thing we have to develop. So every child should be asked some questions, and we have to collect the answers, and we have to understand what is the logic behind. The child doesn't know the exact logic, but teacher can expect the logic behind the child's thinking. That is one. Then deep thinking is very much important. Deep thinking, without deep thinking, deep means you can understand deep water and deep knowledge, like that. So until unless the child thinks a little bit depth, the child cannot think further. For example, a formula is there. For deep thinking, what are the essentials for the child should have? The first information the child should have. For example, if we are teaching a point, a point in the geometry, generally what we give, a point is a dot like that. That will be in textbook or like that. So lots of explanation also will be there, but the teacher do not discuss with the children about that what is given in the textbook. So the teacher has to read thoroughly, and more than that also. And for example, the point is any figure tends to 0 area or volume, that will become point. It may be triangle. So that activity we can give to the child. If you give a triangle, a circle, or any irregular figure also, and you ask the child to listen, what end you will get. So the child will understand the okay, negligible, okay, area of any figure is a point. So another thing is how to locate the point on the paper. This is also very much important. If the pencil is sharpness is not lesser is there, then that shows like a circle or any different area having. So we can ask whether it is a point or this. So the child will understand the how to make that.
Okay. So, as per your suggestion, whatever the activities they give, they must develop intuition as well as deep thinking in the children.
For that, knowledge and understanding also should be there.
Okay.
Yeah.
So, intuition and deep thinking are built with the help of knowledge and understanding.
Exactly.
Okay. So, can you give one or more examples about intuition, sir, Murthy sir?
So, for example, if a student wants to find out the value of 49 times 2.
Okay.
So, directly, how could you say that that is 98? So, if you could just have the institution, regarding institution,
okay,
it might be actually, for example, you will compare that 40 times 2 is 80.
Okay.
But whereas, for example, 50 times 2, 49 is nearer to 50. So, 100. So, you may expect that the value might be
nearer to 100. So, means without doing calculations, he will judge that it is nearer to 100.
He will expect it.
If you give if you give 3 or 4 options,
yes, among them also.
Then he will choose the correct option without having knowledge. Without having even multiplication process also, they can take.
Fantastic.
He will expect.
Doubling.
So, and also, for example, geometry is there.
Okay.
So, if you want to ask, if you ask him to draw the triangle, generally the student will think in his mind that right angle triangle.
Okay.
So, it may not be right angle triangle.
Okay.
So, types of triangle may come here according to the angles or sides.
Okay.
For example, even for if you take, for example, any shape is there, for example, circular shape is there.
Yeah.
If you double it, so what will be its shape? Then you will start thinking.
Okay.
So, if it might be a elliptical way or ellipse or some sort of circle, elongated even ellipse, or it may be some little bit of circle, or another it may be a bigger triangle, which radius may be a double like that, or diameter may be whatever actually. So, this type of thinking should be happened in the minds of the children. Further, before that, there should be a logical thinking rather than rote memory, or before memorizing. For example, if it is doubled, for example, if its shape is doubled, then we will give statement will come, radius will be doubled like that. Instead of that, because you should have some logical thinking in mind rather than rote memory.
Yeah, in nutshell, for every question we have to give options and we have to think these 3 things.
Yes, sir.
One is, did she measured and is telling, otherwise she is applying any formula or any other strategy. So, if you ask the child will tell. Okay, the teacher cannot easily assume that because of this that he knows the formula or he knows the knowledge, he knows the table. We cannot assume. If you understand, if you ask the child, he will give his logic.
Even it may be, sir, some, for example, if you see the figure on the screen, which is far away from that one.
Okay.
But if it is for example, in the sky, we observe in the sky, according to the star, which star is bigger? Can you expect like that?
Exactly.
Okay.
So that distance, the distance will
take into criteria.
Criteria.
Yeah. So intuition is like a very powerful thing, and Ramanujan sir has a very strong intuition.
Exactly.
Yes.
Yeah. Before going to continue our discussion, welcome to Mr. Rangachari sir. He is the retired principal of Degree College, a well-known mathematician, and he worked with Pattabhiramacharya sir regarding Ramanujan sir's works. So actually we know that Ramanujan last notebooks are there, on which Pattabhiramacharya sir worked a lot, and Rangachari sir helped him in doing the works related to that. So it's a great pleasure to us, sir, you are with us. We will discuss about
Thank you.
Ramanujan sir's works and all further. Okay. Sir, further, while talking about intuition and deep thinking, Rayalu sir, you used the word deep thinking.
Yeah.
Actually, what does it actually mean? In what way deep thinking is different from surface level thinking? Because nowadays we can see that in the classroom also some sort of thinking is happening.
Exactly.
So, in what way this deep thinking is different from the regular classrooms happening things?
Yeah, just now we have discussed about the one example.
Yes, sir.
Surface thinking, just asking question and just leaving the children, just getting the answer and going to next step.
Okay.
But in deep thinking, the child should bring out his knowledge and understanding and apply in present situation. Okay.
Oh.
So carefully and critically analyzing information is the first step. Okay.
Oh.
What is analysis? Analysis, if it is a sentence, is a complex sentences, that sentences should be crumbled into small sentences and understand.
Okay.
And then as a whole sentence, the child has to think and understand. That is analyzing.
Okay.
Critically means unbiased and for that context only. Okay. That may be definition. So generally, teachers, we generally give definitions and give one explanation and just we leave. So that is surface level of thinking. Even surface level of thinking, teacher sometimes they do not discuss about the definition. In definition is a collection of words. So each word the child has to understand mathematical meaning. So general meaning and mathematical meaning may be differ. Okay. So that's the reason in mathematics, for example, point is there, or line is there, or addition is there. Addition in mathematics have different numerous definitions. Addition in numbers, addition in sets, okay, and addition in areas, and sometimes this may not go there.
Oh.
So like that, axioms. So all these should be discussed word by word within the child, and we have to get back, understanding, and after understanding, the child has to give his opinion, his construction. Constructive theories we have to apply. What is his construction? Then only he will give, he will make it as a building block. With that building block, he will construct other thing. So this is a little bit logical thinking. Okay, on the major premises, the child will build small minor premises and build a logic, and he will come to a conclusion.
Okay. So this is the core idea of the constructivism.
Yeah, exactly.
So that theory we are connecting here, and if it is happening in our regular classrooms, then it will be more and more helpful.
Exactly.
Okay. So surface thinking, deep thinking. So these two words we are using. So if suppose a child is having deep thinking, or suppose he is having surface level thinking, what kind of things will he do in general? Like means how to improve him to reach deep thinking?
I mean, when a student understands something, he do some answers, he will give you some answers.
Okay,
that is level surface thinking. So if he want to explore it, and if he finds some relation between the terms, then that is called deep thinking.
Oh.
Yeah, in more, what knowledge he has about the terminology or previous problems, he will just put up that before that. But he may not connect appropriation, or even we will see the answer sheets, what the child see the main question and what are the major terms are there, he will start writing.
Oh.
Okay. Explain, describe, distinguish, these words will be there in the questions.
Yes, sir.
So the student will not discriminate between those terms, and what he knows he will put on the paper.
Okay. So that is because of surface level thinking.
Surface level thinking.
Okay.
In deep thinking, he will understand each term and he will start writing that.
So that means we need to convert the surface thinking to the deep thinking.
Yes.
So the
yes.
transformation should take place in the classrooms.
Exactly.
Means it is almost like writing a formula and substituting the values
Yes.
without knowing the logic, how the
Yes.
formula is obtained and all. This comes under surface level thinking. On the other hand, if we understand how this formula is derived and what is the logic behind writing the steps and all, then
How it is suitable to the context.
Oh, okay. So all these things will come under deep thinking.
Exactly.
Okay.
So deep thinking means basically we can say that why? Why does it work?
Oh.
So why do we actually apply this formula? So why do you adopt the method? Why do you adopt this strategy?
So
is there any other method to solve the problem?
Actually, fantastic, sir. Whenever we pose the question why, immediately that comes, are there any other ways for solving the problem? So, multi-method technique will be developed in the students because of this.
Exactly.
Yes.
So, whenever the child has this kind of deep thinking, then definitely he can give different proofs for the same.
And moreover, the confidence building will take place.
Yeah. If it is
Very
algebra
important.
is there,
Independent learning also. Independent learning. He becomes an independent learner.
Okay.
Many uses are there in deep thinking.
The situation should arouse so that he will think more. Then deep thinking comes out.
Yes.
Okay.
yeah, he will
We
change.
need to create situations so that the student will think more and try to find out the relation between those things.
Okay.
That is what we call deep
That
thinking.
means explore by their own.
By themselves. Okay.
In that trials, he will interconnect the areas also. If it is algebra is there, he will try in geometry also. If the geometry is there, in algebra also he will use the formula and he connects. Because he thinks deeply and he brings different kinds of knowledge and connect and again think with that help of that as a basic.
Actually, when you are talking about this, sir, I will go back to my classroom where I found one interesting example.
Nice.
Like in one class, I started working on the areas, mensuration, and square and semicircles were drawn. And the usual method like square and circle areas we are talking about. Then one child started using like area 1, 2, 3, 4 and he started applying linear equations. So he used the help of algebra, even he converted them like linear equations into variables and he solved that. So as you said, really it is a fantastic experience, sir.
Yeah.
Even sir, one example we can give.
Okay.
The sum of the two numbers is 5 and product is 6. The same problem can be solved using quadratic equation.
Okay.
Same problem can be solved using linear equation.
Fantastic.
Same problem can be solved using even linear equations, 2 variables, not 1 variable also, 2 variables also.
Okay.
So this is called as concepts.
Yes, yes.
Okay, concept is by maturity and that deep depth knowledge. Okay, child will show his performance differently and even higher level also. So those such things are concepts. So whenever concepts are there, like that Murthy sir or Sharma sir, how they encourage the children in the classroom, like that every child should get such opportunity. Kindly, all the teachers, please, on mathematics day, Ramanjam day, please take a decision that at least 1 month, one class should be like that. At least 5 minutes of a class should be like that. Thank you.
Okay, sir.
So one more thing I would like to add, sir. Even for example, real number chapter, if you consider, generally in surface thinking, simply apply the formula, Euclid division lemma, and they will find SCF.
Okay.
But whereas actually, why Euclid division lemma works, that has to be discussed.
Okay.
And also even polynomials, simple by substituting the value of the polynomial can be evaluated.
Yes, yes.
But why do we apply that one? But there is a remainder theorem is there. But even linear equations, how to justify each step?
Okay.
In quadratic equation, how do we solve a quadratic equation? Different methods. Why do you say by squaring method and also formula, quadratic formula method, factorization method? Any other method is there that has to be explored.
Yeah. Before that, what Murthy sir told. So for that, teacher has to prepare the ground level. So what knowledge Euclid lemma is there, within that what operations are there. So salvation methods, what the knowledge is there, that knowledge and how far the child is understood that. So there evaluate and make them, trigger them to come to the dais, onto the dais. Okay, until unless we bring the child onto the dais with these references, all those things, the child cannot do deep thinking. Okay, deep thinking is majorly major role is of the teacher. So kindly see that such information is there. For example, if you are cooking tomato curry, tomatoes are essential, oil is essential, mirchi is essential, salt is essential. Until unless we bring onto the dais these, he cannot cook the tomato curry. So think of that, what knowledge is essential and how to prepare the child. Prepare the child, definitely the child thinks in differently. We will astonish the thinking of the child and their language and their reference reflections.
And their priority is also important. Just now,
Yes, sir.
here when you want to cook it, so what item should be started first? What should be next? What should be
The
next?
sequence.
The frequency, the sequence should be there. Without the sequence, you cannot understand. You cannot
And
cook
of course, sir,
you cook the item correctly.
While cooking also, there's so many things like we can talk about
Algorithm.
ratios, proportions, algorithms, so many things.
Right.
That is somehow that are connected with these things. Sir, actually, in our classrooms, they are conducting some activities. But most of the times what happens is the spirit is not continued to the regular classrooms. Like only for a specific day, they will conduct Mathematics Day. Okay, on December 22nd, National Mathematics Day, they will celebrate and they feel that the one program is completed.
Yeah, raat gayi, baat gayi. It's like that.
So, but the question is, how can we take that spirit to the regular classrooms? So, means what sort of activities to be taken up so that you are emphasizing more and more on deep thinking. So, what activities should be conducted on Math Day so that this deep thinking can be developed or built and further it can be continued, not for a single day or two. How can it be done, sir, in your idea?
Yeah, in Mathematics Day, it is a comprehensive thing. Okay, not only about we should not neglect Ramanujan's birthday or Ramanujan's ideas and Ramanujan's economical and mathematical background, all those things.
Yes,
so we need 4 or 5 groups we can make the children.
Okay.
The first group should work on Ramanujan, okay, birth and how he used to go to the school, what books he read, and who gave books, okay, where the books were available, and why he failed some examinations, okay, because of so many the things, because he used to start a problem and he did not complete that problem solution in different ways in stipulated time. That's the reason he failed.
Okay.
Okay, such things, okay, the children should understand and get inspired from that. So for that one, that second is from every chapter of his mathematics textbooks, he has to explain. He has to explain through presentation, maybe PPT or chart or anything, any problem. Okay, like that. Okay, presentations, student presentations are essential. So that second group will work on that. The third group, fun with mathematics. Okay, the fun with mathematics is there in the 8th class mathematics chapter is there.
Yes,
fun with
sir.
mathematics.
Fun with
Other
mathematics
things also. So especially divisibility rules. Okay, can we make a divisibility rule for any number? 7 we generally we do not get, we do not see in textbooks.
Yes, sir.
So for 7, 13 or like that, any number. Actually, why these two divisible by the divisibility rule says that 0 and all the positive even numbers and are divided by 2. So what is the 3? Why we have to add the numbers like that? Such things the children has to present before everything. So this Mathematics Day is for every child and every teacher also. So social studies teacher should not tell that it is not my subject. So kindly all the teachers take my humble request for all the teachers that every teacher has to listen to that and every teacher has to develop a mathematical intuition or a mathematical interest in the children. The third group will be skit and Ramanujan.
Okay.
For example, just now 1729, and he started sum of 2 numbers, sum of 3 numbers, any number can be make into addition of 3 numbers. Okay, like that area of the circle. Okay, pi numbers, e numbers. Okay, like that. So much of vast of things he did. So that is connected with the theory of numbers. He worked so much of lots of things on theory of numbers, beauty of numbers. Okay, why if one number is dividing one number, other number is dividing other number, so what is the product, will it divide, like that. Modular mathematics are like that. So much of things are there. So like that, fun with mathematics. Fourth is lab activities. So already we established mathematical labs in that. So each child will take one lab activity and he will do survey. For example, area of the school, and how much area covered classrooms, how much area ground, how much area garden, so how much area parking. So can be with this little area can be make more useful in that those things, optimization.
Yes, modeling.
So like that, modelization, like that, lab activities, and so many different different things also, projects also they can do, and decorating the classrooms, okay, with mathematical things, that is also. So like that, 4 or 5 groups kindly make children, and according to their interest. Okay, then some collection of mathematicians and collection of the
Day
things,
works.
day works,
Okay.
all those things like that, and they can
We can
hold the day.
We can dramatize the classroom also.
Yeah,
Yes.
role
For
and
example,
skits.
There was a discussion between Srinivasa Ramanujan and Mahalanobis,
Yeah.
a
Mahalnobi.
statistician.
Yes, sir.
That is regarding a house problem.
Yes, sir.
So when Mahalnobi came to Ramanujan, he asked one question. Oh, my house is in a street. The street houses are numbered 1, 2, 3, 4 dash dash dash, so on and so forth. But my house is such that there are numbers on the left side of the numbers, some of the numbers, and right side of the street in the right numbers, they are same. So how do you find? Ramanujan immediately said, your house number is 6. And the street ends with 8 numbers, because some of the first 5 numbers is 15, next 2 numbers 7 plus 8 is also 15. Oh, Mahalnobi said, no, that is a very simple question. So it is still bigger. Then Ramanujan said, oh, then it wants to be 35, and the house numbers are 49. How it can be? Okay, below start adding 1 to 34 and adding 36 to 49, the numbers are same. Oh, then Mahalnobi said, you are very telling easily, but I have one more question. What is that? My house number is more than 50, the last number is more than 50 and less than 500. There came our problems. So if his house number is n, the below numbers are 1 to n minus 1.
Yes.
Okay.
And the next numbers are n plus 1 to the n last number.
Okay.
So he said 1 to n minus 1, the sum number. So n minus 1 into, we use the formula.
Yes.
N minus 1 into n plus 1 by 2. And his house is in the middle. There are once again, the same house numbers are there. The sum is also n minus 1 into n by 2. So n minus 1 into n by 2, n, and again n minus 1 into n by 2. They put together, the last number is capital N, some number. So some of all the numbers, they are also sequence. Therefore, what happens? N into n plus 1 by 2. So summing that, he came to some conclusion. We can algebraically come to conclusion that n square, n minus 1 into n by 2 plus n plus n minus 1 to n by 2 becomes n by 2 becomes n, and the plus n minus n cancel out, you will get n square. On the right hand side, you have n into n plus 1 by 2, n is the last house number. So we have n into n plus 1 by 2 is equal to n square. So here comes. So here I want to add one more thing. What is on your left side? N square. Right side, what you have? N into n plus 1 by 2, bigger n, capital N, last house number.
Okay.
So this is a square number, and there are, you have n and n plus n, those are successive numbers. They are mutually prime. They don't have any common factor other than 1.
Yes.
So this n square must be equal to n by 2 into n plus 1. Either n by 2 must be a square number and n plus 1 is also a square number, or n must be a square number and n plus 1 by 2 must be a square number. Like using this logic, we can find out the house number, so on and so forth.
Yes.
For example, once again, if you come to this street number, last number is 8, then what happens? 8 by 2 is 4, square number, and 8 plus 1, 9, 9 is also square number. So some of the squares, so you can find out the square root. So that is how. So similarly, Ramanujan gave an answer. His house number is 204 and the last house number is 288.
Okay.
288. 288 plus 1 is 289. That is a square number.
Yes, 17.
So therefore he got it like that. So 288 by 2, that is 144. 144 is a square number. N by 2 is a square number. 144 is a square number, that is 12. N plus 1, 288 plus 1, 289, that is also square number. Square root is 17. 12 into 17 is 204. Like that he mentally he did so many problems. That's why his intuition.
Intuition is very strong.
He intuitively, immediately, spontaneously gave the answer that is 204.
Yes, sir. Actually, I read somewhere like whenever this question was asked by Mahalnabis, he said, whenever I heard the question, immediately the answer struck my mind. It must be a continued fraction, like that he answered.
Yeah.
So, such a tremendous personality, immediately by listening the question itself, the answer will come to his mind. That is a fabulous thing.
Yeah, what is the reason for that? So until unless you have lots of tremendous information, all types of information and understanding levels, then only he will go further. Okay, he read Ramanujam read number of books, and he used to bring all the things, all important things to make embed and think latter thinking. Okay,
Yes,
that's
sir.
the reason.
Yes, sir.
So Rangachand sir wants to say something.
Questioning the deep thinking here comes here.
Okay.
So his starting number is 1.
Yeah.
So first he got 6. House number is 6. Second house number he got 35. So if you square it,
Okay.
and this is 1 is there, 6 square minus 1 is 35.
Okay.
That is 6 square minus 1 is 35, divided by 1 is 35. Similarly, 35 square minus 35 square is 1225, minus this number, minus 1 divided by 6 is 204. 204 square minus number,
Okay.
minus 1 divided by its peer
Right,
number
so
gives
that
you
sequence
next
will
number.
come. Yeah.
So 1, 6, 35, 204, and if you calculate it, next number will be 1139.
Exactly. So here,
That is a sequence.
yeah.
There is a relation between the numbers that is there. If your child has deep thinking, he will think over it and he will find out the next number. Even he will find out next number also using this functional property.
Exactly.
Sir, one more, sir, actually, 1 plus 2 plus 3 plus 4 plus 5 plus and so on, infinity is equal to negative 1 by 12. So how did he actually arrive that solution?
That's where. So it requires something using paperwork.
theories.
Paperwork
Yes,
is
yes,
there.
yes, yeah. Of course.
Paperwork
That is
there.
true.
So
Directly
what I
even
want to say,
Here, our usual summation series doesn't work in infinite series.
Yes.
1 plus 2 plus 3 plus you are taking it as infinite series.
It's a
and then another if it's
infinity
minus infinity is also becomes infinite. Infinite.
Yes, yes,
But
sir.
we say 1 is there, 1 is left here. So 1 should be less.
Sir,
If you keep this infinite numbers a little bit forward, so you left with 3 or 4 numbers. If when you subtract it, these 3 numbers should be there, our logical thinking, but it fails there. Infinity, that is the beauty of the Ramanujan.
yes, yes.
So
that's
why
That's
why
a man who knows infinity book was
that's why
written.
someone that English author wrote a book on him, A Man Who Knows Infinity.
Yes.
Yes, sir.
Srinivas Ramanujan is the
And actually, sir, even Ramanujan sir has great memory power.
exactly.
Like while he uses slate earlier, like he write one step and 6-7 steps he will calculate in his mind, and 7th step again he will write on the slate. When children ask him why you are doing like this, means because I have a little space. So to make use of it, I have to complete my problem on the slate itself. So that's why remaining steps he will calculate in his mind and put the like after 6-7 steps again he will write one step, and again 6 steps he will calculate in his mind, and so on.
There is a small joke on it also. Someone asked Ramanujan, why your elbow is so black and white there? He said, I am writing on this and I am rubbing like this. So that's why my hand became so rough and like that. So
Okay.
small
Here
joke.
I would like to add 2 things.
Yes, sir.
One is the teacher role is to arrange the information, whatever the question gets the child, one, or whatever question teacher also gives to the child. So basics a teacher has to give that. The second thing is, in children, what is the observation is there? Lack of attention, paying of attention. Okay,
sir.
so that attention, if you develop within the child, he will sit for much time and he will think in the memory also. Okay, this such activities also with a dhyana, meditation. In meditation, you give a problem. For example, a plus b whole square is there. Okay, that we can, without telling a plus b whole square, you can ask the children to close your eyes and dashadhikena, one rule is there in Vedic mathematics. Whatever you give number 10 plus, within from 10 to 20, dashadhikena, okay, 10 plus 2, 10 plus 1. So think of a square that it is 11, 10 plus 1. Okay, dasha adhikena means one is more than that, and bigger square 10 square, and one other is 10 into 1. This is also 1 into 10, and this is 1 square. So here surface basic information the child need. Okay, a into b, b into a, 1 into 10 and 10 into 1, both are same, that is 10, and this is a sum of all the square, these bigger square and smaller square, and these two rectangles, equal rectangles together is that. So close the child, ask the child to close the eyes, and what is the area of this, what is the area of this, what area of this, what area of this, sum of that and tell. So like that you can give 10 plus 2, 10 plus 3, like that the child will close their eyes, and like this they will develop their attention and dhyana, ekagrata. Okay, so that is very much important. That is the reason Ramanujam used to wrote 3, 4 or 5 steps ahead.
Okay.
Okay, skipping the number steps.
Okay.
So here I'll add one thing.
Yeah, please add.
So even our a plus b whole square is there. So we are not applying it actually. So a plus b whole square, if I take a equal to 1 and b equal to a equal to 10 and b equal to 1, this becomes 10 plus 1.
Okay.
So a plus b whole square is a square plus 2ab plus b square. So I will split 2ab as if I take b a equal to 10 and b equal to 1, it becomes a square plus 2a plus 1.
Yes.
A square plus 2a plus 1. If I split a and a, 2a as a and plus a, it becomes a plus 1. A is my first number, a plus 1 is next number. So if I take a equal to 10, that is 10 square, a square is 10 square is 100. My first number is 10, next number is 11. 10 plus 11 is 21. 100 plus 21 is 121. So what you have to do? You have to square the number, just add that number and its successive number, put together will give you next number square.
Okay.
12 square. 12 square is 11 plus 1 whole square. 11 square is 121. Plus 11 plus 12 is 23.
Okay.
23 plus 121 is 144. So 13 square, that is 12 plus 1. Already we calculated 12 square is 144. And 144 plus 12 plus 13. 144 plus 12 plus 13. 12 plus 13, 25. 25 plus 144 is 169. So our a plus b whole square formula is giving him, go on writing the numbers successfully, squares of the numbers successfully. Even if he knows 40 square is 1600. 41 square is 40 square, 1600 plus 40 plus 41, 1681. So even for minus numbers, you have to subtract. For plus, you have to add.
Yes.
For minus numbers, you have to subtract.
Yes.
Like this, applying the a plus b whole square, the boy will be able to find out all the square numbers continuously, go on like that. But what are there? There are some the steps are there. 10 is known, 15 is known, 20 is known. So you can, if the number is nearer to 15, you have to start from 15. The number is nearer to 20, go from the 20. So for 20, you can have 19 and 21 also. For 15, 14 and 13 also. Like that, the student will, by practicing, by using this formula, and if he applies in the daily life, he'll enjoy.
Oral
mathematics. He'll enjoy.
Oral mathematics.
Nothing but generalization.
Realize, he'll enjoy and he will appreciate the mathematics. He never go back to do any problem. Whenever a problem comes, he feel it happy. Oh, I should be able to do it. That spirit comes to him whenever he solves a problem.
Actually, in the mathematics classroom, the teacher should have patience, sir, I feel. Because most of the times what happens, the teacher will pose the question and they do not give ample time for the student to think over that.
Yes.
That is the major issue. So when once proper time is given for the child, he will think and then he can elaborate in his own way and he can solve the problem. And okay, so related to this deep thinking, we are talking about different activities. For example, say we are talking about explanation say why the reason must be there. So then you just observe the screen, like one activity can be taken up. So explanation booth, like one activity we can take up. Means we will give some questions and we will ask the students to write the reason. We say they have to tell the reasons for that. So like this, we can conduct some activities in the school which will lead to deep thinking.
Especially in geometry.
Yes, sir.
Especially in geometry and algebra.
Okay.
In algebra, every step, future step, what the child is doing or writing. So we have to ask the connection between previous step and present step. What is the logic? So he will tell, because of this rule, because of definition, and because of formula, because of axiom, I am writing this.
Okay.
So like that, evidences, okay, make the child to confident with for each step, and that authentication also will come and in solving the problems. Okay, that is very much important. Logical reasoning. So we have kept as our Rangachari sir said, visualization.
Yes, sir.
That is okay. Child can close his eyes and visualize 11 square. Okay, how it is done, or 356 square. Okay, how
Yes.
how it can done. That is visualization.
So actually, mental mathematics,
Oral
that is
mathematics, yeah.
oral mathematics or mental mathematics, we can say, like in the mind itself, they will calculate.
Yes.
And actually, when we talk about the activities, like earlier you said, role play.
Yeah.
Instead of going for the routine activities, we can ask, like even in my school, I conducted an activity, like one girl wear a cube, and she imagined or personified herself like a cube, and she started saying how many faces you have. I have 6 faces and so on, like some kind of dramatization.
Basic properties.
But the basic properties are like the children will understand it in a more better way.
Exactly.
Such kind of role plays will give them some sort of fun will be there, some sort of creativity will be there. Yes. So altogether it will give a memorable experience for them, as well as the things will be continued in their minds further.
Exactly. National Education Policy also suggests curriculum, art education across the curriculum.
Yes, sir.
In art education, creating some figures or and doing the dramas and okay, like that role play and whatever thing visualized, they can okay show on the papers, drawings and model making like that. This is art education. That also we can develop, encourage the child in comprehensive knowledge. Mathematics is not a single item. Okay, we can see in the culture, we can see in the dramas, we can see in the monuments, we can see in the temples, we can see in the mosques. Okay, buildings are like that. All these things we can ask the children to collect information and bring that.
Sir, like okay, so because we have very less time, Ramanujan means magic square, so we have limited time, so just we will discuss only one magic square. Just look at the screen, a 3x3 magic square. How can it be filled? Like there are different techniques for filling this. Just observe this. This method is called cross move technique. Actually, like we can imagine it like a 3-dimensional way in which if you imagine how to fill these numbers, we can understand. So this is one way of filling, and of course magic squares
This
means
is a knight method also. In chess,
Yes,
chess, how the knight will move. Knight ante horse. Yeah.
so so ultimately Rangachari sir, in one word, what you suggest for the teachers for inspiring the young minds?
Young mind, right? So whatever they see in the practical, that should be brought to the classroom. Whenever whatever they find in the real life, that situation comes to the classroom, then the student will understand the thing very mostly.
Okay.
So that is how we should bring the classroom life situations into classroom.
Okay. That's fantastic.
I will add something here.
Sir, Murthy sir, what is your conclusion statement related to this?
One thing, sir, actually, whatever is there actually, practical, it is to be connected to the daily life situation, as well as problem solving strategies has to be improved.
Okay.
And also moreover heuristics has to be used.
Heuristic.
So heuristics means that is nothing but actually the strategy of solving the problem in different methods rather than rote memory itself only. So there are several heuristics are there.
Yes.
So that can be discussed clearly later. So if they adopt all these things, definitely the student will flourish in mathematics. They will enjoy the mathematics. The mathematics can be made fun.
Sir, Rahil sir,
So if you show this magic square again, please show.
yeah.
Yeah, here we can ask the children, why if 8 is in the middle square, what will happen? So if it is 8 is more number, so we cannot get 9 plus 5, 14 plus 5, 15. 8 is there, 7 there, and the one block will be without number. So which number will be in the middle?
Okay.
So that will give heuristic approach and the child deep thinking. So they will put each number and think, what are the combinations of the 3 numbers, okay, and
also
to get that.
One more sir, actually the middle number is 5. If you multiply with 3, 15 will be the magic sum.
Magic sum.
Yes.
Yes.
So that will be explored by the children itself only.
Yeah.
Yes, sir.
So three square magic square is there, and middle number is 5.
Yes.
That if it is 5 square is there, 5 and middle number. Okay. So that is the sum.
That's the reason.
Okay, viewers, till now we discussed about the different mathematical day activities. So the basic idea that the experts gave is while conducting the math day activities, you please see that the intuition and deep thinking are developed in the activities which were chosen, and please continue these activities further in your regular classrooms also. It is not for a day or two, not only meant for that specific day. We have to continue it further in our regular classrooms also, weekly ones or quarterly ones, like we have to conduct these activities so that the probing nature, the creativity, we have to give scope for such things through our activities. So select the best activities and try to inspire the young minds as much as possible, so that maybe, who knows, one day your class student may become one more Ramanujan.
Yes, sir.
We actually wished the same thing from our end. Okay, thank you. So actually these are the activities which you can conduct in your schools, and you can make it more successful. Happy Mathematics Day in advance for 22nd December. Thank you one and all.
Thank you.